Problem number 2, we're going to fill in our missing blanks here. And on this particular problem, we've got JL bisects angle NKH. And then we also know that line segment JL is parallel to FI. And we want to prove that angle 1 is congruent to angle 4. So actually, I'm glad that down here, as I look at the proof a little bit more carefully, line JL bisects angle NKH, and then it's really that line JL is parallel to FI, and those are given reasons. And what we have here for our next statement is that angle 1 is congruent to angle 2. And if you think about it here, it says JL bisects angle NKH. So angle 1 is congruent to angle 2 because of the fact that it's the definition of an angle bisector. We also have that angle 2 is congruent to angle 3. Well, if we once again remind ourselves, JL and FI are parallel, which means that MH is a transversal, and we've got angle 2 here, and now we have angle 3. Angle 2 is underneath the parallel line and to the right. Angle 3 is above the parallel line and to the left. And what happens there is that those are interior angles as well as on opposite sides. So this is the alternate interior angle theorem. Our next blank, we know that we are talking about vertical angles, but we need to go back here and figure out what needs to go in there. And what I see is that angle 3 is a vertical angle to angle 4, so we can say that angle 3 is congruent to angle 4 because they are vertical angles. So now we've got a bunch of statements. We've got angle 1 is congruent to angle 2, angle 2 is congruent to angle 3, angle 3 is congruent to angle 4, and now we have that angle 2 is congruent to angle 4. So if you notice here, 2 is congruent to 3, 3 is congruent to 4. We're transporting 2 across 3 to end up with 4. That is the transitive property. And in fact, to get our final statement that angle 1 is congruent to angle 4, we're doing the same thing now. We had 1 is congruent to 2, 2 is congruent to 4, so we're transporting 1 across angle 2 to end up with 4, and that is the transitive property as well.